If evolution by natural selection were a person, it would be the ultimate C student. It wouldn't be trying to get straight A's by putting together a perfectly crafted organism. For it, good enough to pass, aka survive and reproduce, would be good enough. And that's how you end up with animals whose anatomy is just messy, but functional. For example, take the nerve that connects the brain and the larynx, or voice box. In ancient tetrapods, that was a pretty short, direct route. But in modern giraffes, it travels from the brain down the neck around the aorta and then back up the neck to the larynx, because that route still works fine, even though the giraffe's neck is really long. Amphibians aren't exempt from this kind of messiness either. Like, there's even a frog that is so small that its inner ears just kinda don't work. Meet the pumpkin toadlets, a group of tiny frogs that live in the Atlantic rainforest of Brazil. And yes, it is confusing that they're somehow both toadlets and frogs. The truth is that all toads are frogs, and the two categories are actually taxonomically meaningless. We just tend to call the ones with rough, dry skin and shorter hind legs toads, while the moister, hoppier ones are frogs. The closest relatives of the pumpkin toadlets themselves are often called flea frogs, and they're in the same genus. Pumpkin toadlets are mostly active during the day, especially during the rainy season. They live in leaf litter that collects on the forest floor, where they hunt for small arthropods and insect larvae. And when I say these guys are tiny, I mean tiny. Pumpkin toadlets tend to be less than 2.5 centimeters in body length. And being that small actually makes them seem kind of terrible at being frogs. At least to us. To our hypothetical C student evolution, they've obviously achieved good enough because they managed to exist. See, there are essentially three things that are pretty fundamental to an animal's biology: how it gets around, how it eats, and how it reproduces. And pumpkin toadlets seem to be bad in a certain sense at two of them because of their tiny size. They're fine at eating though, so good work on that one at least. But at least 4 species of them are terrible at landing their jumps because they are just too small. See, being that small means that their semicircular canals are also really small. Those are the 3 looping canals found within a vertebrate's inner ear. They're filled with fluid, and they help an animal detect where their body is positioned in space, how fast they're rotating, and how fast that changes. This sensory feedback helps an animal know how to move the way it needs to. And the canals kinda look like a tiny folded up pretzel. Now, pumpkin toadlets have the smallest recorded semicircular canals for adult vertebrates, and this comes with a particularly silly looking consequence. The tiny size of their semicircular canals impairs the vestibular system, which is the system responsible for balance and spatial orientation. Basically, the fluid in their canals can't slosh around well enough to tell them where they are in space when they're rotating or moving fast, because the canals are just too small. And this means not a lot of stuck landings when they jump. They just kind of cartwheel or flop goofily through the touchdown. Pumpkin toadlets are also not great at reproduction, or at least the lead up to it. I mean, they obviously get the job done somehow, but at least 2 species of them probably can't hear their own calls. And in most frogs at least, calling is how they find mates. But these guys are really just shouting love songs to no one. And the reason for this odd quirk of their biology? Yep, it's their inner ears again. This time, it's not the fault of the semicircular canals though. It's a part of the hearing apparatus called the basilar papillae that's underdeveloped. It's essentially missing 2 pieces, and a third isn't organized like it is in other frogs. And these missing and disorganized parts mean that they can't hear high-frequency sounds, like their own calls. And yet, they keep peeping for mates anyway. It obviously works well enough. The researchers think that the look of calling, like vocal sac movement, might have replaced the sound of calling as the signal being transmitted. The toadlets are active in the daytime and brightly colored, and they do some other visual signaling to communicate, so it's possible that potential mates can see them going through the motions of calling. It's also possible that the frogs can get away with giving away their position because they're highly toxic, and predators know to avoid them. And after they do manage to find a mate, they don't do the typical frog thing of laying eggs in a pond that hatch into tadpoles. Like the sandhill frog and the turtle frog we talked about in a previous episode of Bizarre Beasts, pumpkin toadlets have what's called direct development, where their eggs hatch directly into even tinier toadlets. If all of this wasn't strange enough, the two species who can't hear their own calls also have luminescent bones, much like the chameleons we featured in our first episode. The skin on their backs and their heads is thin enough that their bones fluoresce under UV light, which is actually a pretty normal thing for bones to do because of their chemical composition. Whether or not other pumpkin toadlets or predators can actually see this fluorescence in natural lighting conditions still needs to be studied though. All in all, pumpkin toadlets are a delightful little mess of a frog. They've really achieved good enough in spite of their tragic landings and love songs to no one. And hey, who are we to judge? The C student of evolution got a passing grade on us too, in spite of the bad knees and backs that come from turning a four-legged ancestor into a two-legged human. The Bizarre Beasts Pin Club subscription window is open from now through the end of October 17th. Do not miss out on the pumpkin toadlets! When you sign up, you'll get the toadlet pin in the middle of the month and the pins after that around the time each new video goes live. We've also sold more than half of our Bizarre Beast calendars, but you can still order yours at complexlycalendars.com or click the link in the description. And as always, profits from the Pin Club and all of our merch go to support our community's efforts to decrease maternal mortality in Sierra Leone.